Hi, and welcome to lesson 3.4, Find and Use Slopes of Lines. So the idea of a slope should be a repeat. So part of this lesson is a refresher from Algebra 1. But what you want to remember is a slope is the vertical change in a line over the horizontal change between any 2 points on the line. So our slope is the ratio of vertical change, the rise, to horizontal change, the run, between 2 points on a line. So slope is always represented with a lowercase m. So m equals rise divided by run. Or we can think of that as change in y over change in x. And change can be represented with the delta symbol, which looks like a triangle. So delta y over delta x means change in y over change in x, which then the algebraic model, the most useful to us, would be one of the y coordinates minus the other, so y sub 2 minus y sub 1, over x sub 2 minus x sub 1. And then slope-intercept form, our most common form for a line, y equals mx plus b, the m is always your slope. So just a few things to keep in mind, refreshers from Algebra 1. Then if we have a positive slope, it would look something like this, rising from left to right. If the line is falling from left to right, we'd have a negative slope. If it's a horizontal line, we have a zero slope. And if it's a vertical line, we have an undefined slope. So now, building off of what we did in algebra, we move into the postulates that relate slope to geometry. So the first postulate is slope of parallel lines. And it says in a coordinate plane, so coordinate planes are just your XY graphs that you graph on. In a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. Any vertical lines are parallel to each other. Same with any horizontal lines. So if lines have the same slope, they are parallel. Now the postulate 18 is the slope of perpendicular lines. In a coordinate plane, if two non-vertical lines are perpendicular, if and only if the product of their slopes is -1. So if you multiply the two slopes together and they equal -1, then the lines are perpendicular. So an example of that would be a slope of 1/2 and a slope of -2 or -2/1. Those two multiplied together equals -1. So lines with these two slopes would be perpendicular. So in example 1, we're just going to practice with finding the slopes of given points. Now remember, your coordinates are always written x, y. So the x value is the first, y value is the second. Now, change in y over change in x, it doesn't matter which y value we start with. We could start with the 2 or the 6. If I started with the 6 on top, then for the x on bottom, I'd have to start with the coordinate attached to it, or the 2. If I started with the 2 on top, so 2 minus 6, then my bottom would have to start with the coordinate attached to the 2, which is a 0. So I started with the 6, so change in y, 6 minus 2, over change in x, 2 minus 0. That simplifies to 4 over 2, which simply gives me a slope of 2/1, or 2. In B, we have a -2, 2 and a 3, 0. So change in y values, I'm looking at the 2 and the 0. So I started with the 0, 0 minus 2. Because I started with the 0, I have to start with the 3 on bottom, 3 minus a -2. So on top, 0 minus 2 is a -2. On bottom, 3 minus a -2 is a +5. So that slope would be a negative 2/5. And in part C, we have a negative 4 comma negative 7 and a negative 4 comma 2. So change in y on top, 2 minus a negative 7. Change in x on bottom, negative 4 minus a negative 4. 2 minus a negative 7 on top is 9. A negative 4 minus a negative 4 on bottom is the same as negative 4 plus 4, which is 0. And in math, you cannot divide by 0. Division by 0 is undefined. So what that tells me is this is a line that would end up being a vertical line. If the slope is undefined, it's a vertical line. Then we move to example 2. Tell whether the lines through the points are parallel, perpendicular, or neither. So remember, to be parallel, the slopes are the same. Perpendicular, the slopes multiply to equal negative 1, and anything else would just be neither. So in part A, line 1 is at the points 1, 1, and 3, 3. So change in y over change in x, 3 minus 1 on top, 3 minus 1 on bottom. So our slope is 2 over 2, which is 1. Line 2 has coordinates 1, 3, and 4, 6. So change in y on top, 6 minus 3. Change in x on bottom, 4 minus 1. It's 3 over 3, or 1. So the two lines have the same slope, meaning they are parallel. In B, line 1 has the coordinate negative 3 comma negative 2 and 1 comma 2. So change in y on top, 2 minus a negative 2. Change in x on bottom, 1 minus a negative 3. That gives me 4 over 4, which equals 1. For line 2, change in y on top, 4 minus 2. Change in x on bottom, x minus 2, gives me a negative 2 over 2, which simplifies to be a negative 1. 1 multiplied by a negative 1 is negative 1, so these two lines are perpendicular. And then in part C, line 1, negative 2 comma 3 and negative 5 comma 2. So change in y on top, 2 minus 3. Change in x on bottom, negative 5 minus a negative 2. So on top, 2 minus 3 is a negative 1. On bottom, a negative 5 plus 2 is a negative 3. Negative 1 over negative 3, the negatives cancel, so we're left with 1/3. In line 2, coordinates are 4, 1, and 5, 3. So 3 minus 1 on top, 5 minus 4 on bottom, gives me a slope of 2/3. They're not the same, and they don't multiply to equal negative 1, so these would be neither parallel or perpendicular. Now example 3. Graph a line through the given point with the given slope. So when you're graphing these lines, you want to start with the point that they gave you. So my given point is 2 comma 2. So you always start at the origin, 0, 0. The x value tells you left or right. So in this case, I have to go right 2, up 2. The y value tells you up or down. So my point's right here at 2, 2. From that point, you follow the slope, which is rise over run. So if my slope is 3, that's the same as 3 over 1. So from point 2, 2, I would go up 3, 1, 2, 3, and right 1. You could also do the inverse, down 1, 2, 3, left 1. That gives us our points to connect and draw our line. So in B, we want to start at our point of negative 2, negative 4. So we start at 0, 0, go left 2, down 4. From that point, our slope is 2 over 3. So rise over run, we would go up 2 and right 3. There's your next point. From that point, up 2, right 3, there's your next point. Connect your points. You technically only need 2 points to draw a line, but I always check and create 3 points, so then I know my line is accurate. So in part C, we're at a -1, 5. So from 0, 0, left 1, up 5. And then our slope is a -3/4. So what that tells me is go down 3, 1, 2, 3, right 4, 1, 2, 3, 4. So if I ever have a negative slope, I always go down and then right. So instead of going up and left, we go down and right for the negative. You could go up and left as well. If we went up 1, 2, 3, left 4, that would be right here. But because of the negative, I never want to move to the left. So I just go up or down first. So if I have a negative, I'm going to go down 3 and then right 4. Down 3, right 4. Example 4 tells us line H passes through 3, 0, and 7, 6. They want us to graph a line perpendicular to H that goes through point 2, 5. So the first thing I'm going to do is just graph H. So I put my point 3, 0, put my point 7, 6, connected them, so I had line H. Then what I want to do is figure out the slope of line H. So change in y over change in x. 6 minus 0 over 7 minus 3. That is 6 over 4, which simplifies to 3/2 or 3 over 2. I never write my slope as a mixed number. I either leave it as an improper fraction or a whole number, or usually those are your 2. Every now and then you'll see it as a decimal. So if I know the slope of line H is 3/2, the line perpendicular to that must have a slope of -2 over 3, because a -2 over 3 multiplied by 3/2 equals a -1. So then I know my perpendicular line has a slope of -2/3, and they want it to pass through 2/5, or 2, 5. So I'm going to start over 1, 2, up 5, and that's where I know 1 point on my new line has to be. From there, my slope is down 2, right 1, 2, 3. That gave me the point where it would cross H, so then I can draw in my new line that crosses through line H at 90 degrees, or a perpendicular angle. Then we get example 5, the last one for this lesson, which is about climbing the mountain, Magnum XL, or not climbing the mountain, climbing the roller coaster. So the climb on the roller coaster, Magnum XL 200. So we're moving 41 feet upward at a rate of for every 80 feet you move horizontally. So every time we go 41 up, we're moving 80 horizontally. At the crest of the hill, we've moved 400 feet forward, so 400 feet horizontally. So what I know is if I'm going 41 feet up and 80 horizontally, my slope would be 41 over 80. So make a table showing the height of your coaster for every 80 feet. How high is the coaster at the top of its climb? So I'm going to make my table with y over x to match the slope. So if we didn't move at all, y would be 0, x would be 0. When y goes up to 41, x is at 80. So when we go 80 feet over, 41 up. Our next 80 feet over, 160, we would have to add another 41 to the top, which would put us at 82. Then another 80 feet to the right, another 41 up, another 80 to the right, 41 up, 80 to the right, 41 up. So my height at the top of the climb would be 205 feet. So what fraction represents the slope? That's just 41 over 80. And then another roller coaster, the Millennium Force, climbs at a slope of 1. At its crest, the horizontal distance from its starting point is 310 feet. Compare the climb by graphing both and then saying which is steeper. Ignore this little quiz part there, that was a typo in there. So in this case, what I'm going to do first is I'm going to deal with my Magnum XL slope, which was 41/80 from the previous problem. I know I started at 0, 0. So then I could go up 41, right 80, up 41, right 80, up 41, right 80, and so on. And that would give us our blue line here. The pink line has a slope of 1, and we know that from its starting point, 310, doesn't really matter. Because if my slope is 1, what that tells me is every 1 foot I go up, I would go right 1 foot. So every 100 I go up, I would go right 100. Every 200 I go up, I'd go right 200. So in this case, we would just set our slope here of 1 for the pink line. So at 0, 0, then I could go up 10, right 10, or in this case, because my scale is 100, I could then go up to 100, right 100, up to 200, right to 200, up to 300, right to 300, and so on. And in that case, the Magnum or the Millennium Force, pink line, the Magnum XL blue line, which one has a steeper climb? It would be the one with a slope of a 1 being steeper. So in this case, whichever one has a bigger slope would be your steeper line. So you can see practice problems there at the bottom, but the main idea for this lesson is just be careful with your idea of slope, change in y over change in x, and then the 2 new postulates for the special relationships of parallel lines and perpendicular lines.